Welcome to the Things Fundamentals on LoRaWAN Security. Today, we'll discuss how LoRaWAN messages are encrypted and what that means for your application data, how to securely and scalably onboard LoRaWAN devices, and other best practices for building secure LoRaWAN networks. Of course, I'll also share some more resources so you can keep learning and get started building your own LoRaWAN solutions. I'm Ben, I'm the technical writer at The Things Industries. Let's get started. Today, I'll quickly remind you why LoRaWAN is awesome. I'll discuss the pillars of internet security. We'll talk about the different layers of security in LoRaWAN and what a session is. Then, we'll discuss activation, join servers, and finally, we'll discuss some best practices for implementing secure LoRaWAN networks. So again, why LoRaWAN is so awesome? Lots of reasons, and one of them, as you can see, is end-to-end security. LoRaWAN was designed from the ground up to be secure. Authentication and encryption are mandatory in LoRaWAN implementations, using modern 128-bit AES encryption. Implementation matters, though. A secure protocol doesn't protect against a person exposing root keys in plain text, or poor implementation which reuses simple root keys. LoRaWAN implements two-layer security, using separate keys for the application and network. This means that the application data which the end user sees is encrypted inside the network layer and cannot be accessed without that separate key. Encryption of LoRaWAN packets looks like an onion. In the middle, you have data, say a temperature or a button press. When a device or application communicates, that data gets encrypted by the application. Then, it gets encrypted by the network. Then, it might also get encrypted by the protocol it's traveling on, say HTTPS with TLS. It's important to note that once the network encrypts the data, it is totally secure. And additional layers do not really protect the message more. They just prevent attacks on that medium, like replays. The physical layer that LoRaWAN travels on, LoRa, has no security built in. All the security is implemented in the software LoRaWAN layer. The physical layer just has a CRC to detect errors. All of this encryption produces what's called a session. The network session allows the network to locate the device, and the application session tracks the number of messages and provides the last level of encryption. There are two ways to activate a device and create a session. Over-the-air activation involves storing root keys in the device and network, which are then used to negotiate new session keys for each session. Activation by personalization involves hard-coding session keys into the devices so they can never change. This is done in some cases to avoid having to negotiate keys, but it has several drawbacks. Over-the-air activation is more secure because new session keys are negotiated between the device and the network for each session. Since ABP involves hard-coding these session keys, if they are compromised, all future and past traffic is also compromised. There have been papers published in which poor ABP implementations, which reused keys, were exploited when attackers listened to an ABP message in one location and then played it back for other devices which used the same keys. Again, implementation matters for security. For example, it's important to use a secure connection between the network server and the end application. It's also important to know what information is not encrypted. During a join procedure, join EUI and dev EUI are transmitted publicly. This means that an attacker could figure out where your root keys are stored by the join IP address. So it's important that that's secure. The dev EUI may indicate the module and version of your device. If you're using over-the-air activation, you need a secure way to share root keys in the device with the network. The best way to do this is with a trusted join server. A join server allows the device manufacturer to securely share device root keys, and the join server then generates session keys, which can be shared with the network to authenticate a device without ever compromising those root keys. LoRaWAN has some more security filters built in. Message confirmation assures that packets are being received, and frame counters prevent replay attacks, for example. Finally, here are some tips for implementing secure LoRaWAN networks. Never expose root keys, and do not reuse keys for multiple devices. Using over-the-air activation and a join server allows for flexible, secure device activation. Now that you're a LoRaWAN security expert, let's talk about getting started. To prototype your first LoRaWAN solution, we recommend the Things Network, where you can use the free The Things Stack Community Edition, which has coverage from tens of thousands of gateways all over the world. Once you're ready to scale your solution commercially, reach out to The Things Industries for an SLA-backed, enterprise-grade, private LoRaWAN deployment, either in the cloud or on your own hardware. Thanks for watching.